So we'll continue with the acid rain. So as we mentioned before that there's a certain of gases that can evaporate then in the atmospheric system. For example, the green gases, the greenhouse gases, as the effect of there's a lot of things here occur in the surface of the earth. There is industrial activities that can produce nitric oxide, the sulfuric oxide, even the carbon dioxide as a part of the uh, burning the fossil fuel. So the emission of those gases into the atmosphere are released into the air, and then when they get a contact with the water in that atmospheric system, they could form the acid rain. The acid rain basically is just like a rain, but they have the specific properties. For example, they have a lower pH because of the gases. The For example, the sulfuric oxide or nitric oxide, they form the acid solution. This is, for example, the sulfuric oxide when they get react with water, they got the sulfurous acid solution. And when they got the sulfuric oxide and then they got contact with water and then there is oxygen, they can form the sulfuric acid. The other example, if they have a nitrous oxide and then there is oxygen and water, they can form the nitric acid. How about the carbon dioxide or carbon monoxide? If they got carbon monoxide and carbon dioxide and then they got contact with water, they can form the carbonate acid solution. Those all the acid solution, they will combine get mixed with the water during the rain system, and then when the rain pours, showering the area, for example, uh, here, the residential area or even the river or ocean, those water drops has the lower pH, and then they give some effect because basically this acid solution is not really good for human health or even the building and the cars, because the acid solution can form a typically some kind of reaction with the metals, for example. So the acid rain basically the pollution that are transformed into acid particle that may be transported long distance. This acid particle then fall in the earth as a wet and dry deposition. So all of the gases when they make or react with water, they can form as a wet deposition as a rain, or also the dry deposition as a dust, for example. This is typically some of the impact of the acid rain, as we know that the corrosion, because again, with metal meets the acid solution, they typically will start the corrosion because the acid solution initiate the oxidation reaction on the surface of metals. This is for example, as we can see here, when there is a broken car in the backyard, and then there is an acid solution occur under the area, and then they hits the metal, and then the metal will, start oxidize and then form the corrosion. The other example is typically occur in Indonesia, mostly because we are the agriculture country, when there is a lot of like soil with the high carbon contents in maybe a long time ago, and then due to the lot of pollution in the area, and then the area got the acid rain very intense, and then again the acid solution when they meet the organic carbon, they can like wash all of the organic things, because organic can get easily dissolved with the acid solution, leaving the soil without any organic carbons or organic contents. The soil without the organic contents will make the soil get dry, and then they call it the soil degradation, which means that soil cannot support the living plants on the surface of the soil system, leaving the area become so dry. The other example is the building destruction. As we can see, the area with a very high pollution, with the very intense acid rain, they will get some destruction on the building. As we know that the building, the concrete and everything. They got the calcium on the concrete system, and then when the acid rain shower the building, and then the acid solution will extract the they will extract the calcium on the building and then start to form calcium carbonate. The calcium carbonate typically is a white form solids that could form like a very um, random formation. For example, here they just try to form a lot of things here. In the area of forest, for example, or the open space area where there's a lot of plants, the acid rain also gives some effect for the plants. As we can see here, the leaf of the plants get burned or get browny on the area of the leaf, leaving indicating that the leaf itself get destroyed by the presence of the acid rain. As we know that the leaves contain a lot of organic things, and then will when they get contact with the acid rain very intense, all of the organic compounds will get destroyed and then leaving the leaf brownish or get burned. In some area with a very extreme acid rain presence, they could make the environmental collapse, where, as we can see here, all of the trees that destroy by a very high amount of acid rain shower on the area. For talking about the human impact of the acid by the acid rain here, there's a lot of things that can be occur because of the acid rain. When I was a kid, and when the acid rain coming and then they get hits my head, they will they will like the acid rain basically could initiate the dizziness on my head. Then that's why like when we got the rain in the first like first 5 minutes during the raining session, it's the parents always say that, okay, don't get shower on the rain because it's acid rain and can make you dizzy, and then if you got the rain, just try to wash your head as soon as possible. That's also the one of the side effect of the acid rain for human impact. The other thing here, as we can see here, the acid rain can also initiate the asthma when a lot of academic studies report that the acid rain can make the asthma worse compared to the one with the lower acid rain presence. Talking about the acid rain is also correlated to carbon dioxide in water, as we know that carbon dioxide in water can also dissolve in water or also present as a gaseous phase in the atmospheric. Carbon dioxide can form as a aqueous solution or in the water system, and also could form in the atmospheric system. As we see that the animals, the plants could like extract or contribute in the cycle, where the massive activities, for example, natural disaster, industrialization, direct burning of biomass could uh, contribute more on the carbon dioxide uh, production in the atmosphere. So the carbon dioxide is specifically on the atmosphere, and then they get react with water. They will form the carbon uh, carbonate acid or carbonate acid, and then the carbonate acid when get like drops and in the ocean and then get react with the seawater, and then they try to make the seawater a lower pH, because again the carbonate acid solution is also typically an acid solution that can like form a lower pH on the seawater. The carbon dioxide here could be determined by the amount of gas or its ionic form. So a lot of scientific activities report to quantize the amount of carbon dioxide in water. Uh, the idea to count how much the carbon dioxide in the water system just to calculate the amount of gas and its ionic forms, either in bicarbonate or carbonate ions. The presence of ionic forms, for example, the bicarbonate or carbonate ions, increase the solubility of carbon dioxide in water. It means that if there is a carbonate or bicarbonate ions on the water system, for example, in seawater, those ions can interact more carbon dioxide to get absorbed on the seawater, leaving as lower or higher carbon dioxide on the seawater. This is, for example, calcium carbonate. When they got the carbon dioxide and water, they try to make more bicarbonate ion and the calcium as the ions. This is typically a very dangerous things because, as we know, the calcium carbonate can a lot of shellfish and corals in the ocean. They has the calcium carbonates as one of the most compounds consists of their shells or corals. And then when there is a acid rain, or there is a lot of concentration of carbon dioxide on the seawater, for example, the carbon dioxide could extract the calcium from the shell or the corals, leaving the corals lost most of the calcium on the coral or the seawater ecosystem. This is not really a good idea, especially this it could become a disaster, because when the acid rain, especially, or high concentration of carbon dioxide in the seawater, we could lose all of the creature, for example, the coral, shellfish on the ocean, because the seawater itself can dissolve all of the calcium on the seashell and the corals, which is basically uh, protect the sea creature from the environmental threats. Yeah, this is not really good idea. Some journals already report that the corals right now, like form in the smaller size compared to the one that reported maybe 15, 20, 30 years ago. The smaller forms of the corals is indicate that the seawater in the ocean is getting lower pH. That meaning that the lower pH could, like dissolve more calcium on the seawater, forming the smaller coral on the ocean system. This is the other terminology of the ocean acidification, which is the progressive decrease in the pH of seawater, caused primarily by the absorption of anthropogenic carbon dioxide emitted into the atmosphere. So again, because of the seawater has the bicarbonate or carbonate ions, and then they can get interact with the carbon dioxide in the atmosphere, and then making it more concentrate carbon dioxide in the seawater. This make all of the calcium containing on the seashell, corals, mollusks, and other marine calcifier, get loss of the calcium, and then leaving the calcium ion in high concentration in the seawater system. The other scientific journal that I mentioned, it's published in 2026, just a couple, even like it's already published online. They say that the ocean acidification also provides some effect on the zooplanktons, and it's also initiated by the rising the temperature due to the climate change. But the acidification on the ocean system stimulate more zooplankton growth on the system, on the seawater system, which make the seawater ecosystem getting worse. Again, this is the combination effect where the rising temperature during the climate change and also the ocean acidification due to the massive amount of gases releasing on the atmospheric system, like getting the system or the ecosystem worse than before. So again, this is not really good fact that most of the environmental engineering students should think about how to prevent those uh, those uh, uh, phenomena. Yeah. So as we can see, like we just really uh, sad with this fact that we will lose not only the things on the surface of the earth, I mean like the land, but also something on the ocean too. As the executive summarized from the first meeting, second meeting, on the third meeting, I will try to summarize the key point that I will share with you today. That as we know that water is reported as the most powerful compounds in the universe, as we can see that water itself consists of almost 70% of on our body, and then it's like water itself can be found anywhere. The hydrogen bond in the water molecule determines the role of those powerful properties. For example, the excellent solvents, due to the polarity, the dipole molecules, and etc. The hydrogen bonds play as the man on this water molecule itself. The excellent solvent made water easily react with serious substance through different pathways. In the second meeting, we mentioned that the excellent properties, especially as a solvent of a water, make the water can get easily react with a series of substances, including the pollutants, the chemicals, and even the gases. The easy reaction with those substances and molecules make the water can get destroyed easily or get polluted easily, making that the sustainability of water purity can be destroyed. The reaction involved in water is also conducted in the atmospheric system, meaning that the water can get react not only in the soil or not only in the water itself, but the water can react with the gaseous phase of pollution. Oceanification and acid rain are the example of product of water interaction in the atmosphere. Like we mentioned in this meeting, that the effect of the water react with gases in the atmospheric system is the ocean acidification, which means that the seawater get a lower pH than before, and also the acid rain, meaning the rain itself, the natural rain getting low contains some type of acid solution that make the rain has the lower pH. They have a bad effect not only for the living organism but also for building, and also the things like cars, the metal-based material. The sustainability of water purity will determine the sustainability of us, meaning that we have to think about how to make the water sustain, how to hold, or how to maintain the purity of water. Because again, as we learned during this session, like last session also, that the presence of water in the environment is in the high threatened, where not only in water itself, but also in the soil and the atmospheric threat is really high to destroy the purity of water. That's why like we have to maintain the sustainability in water purity by use the proper water system, and also try to ensure that the water hydrological cycle or water system cannot get destroyed by our anthropogenic activities, for example, the industrialization, agriculture, and etc. Again, this is the last thing that I want to show you before we end. Thank you again, and I wish you luck. Assalamualaikum warahmatullahi wabarakatuh.